In this video, I'm going to talk about solving quadratic equations by factoring. So there's lots of ways to solve a quadratic equation, but in this video we're going to focus only on one of those methods, factoring. So we have x squared minus 2x minus 15 equals 0 for our first example. So we're focusing on factoring this left side. So I notice that this is going to be the easy method of factoring because there's just a 1 out here as a leading coefficient of my quadratic equation. So I know it's going to be something like this, and I need to find the factors that multiply to make negative 15 that add to make negative 2. Well, I know since it's negative 15, I'm going to have one positive here and one negative, so one of each sign. And my factors of 15 that are 2 apart are going to be 3 and 5, and the larger those will be negative. So my 5 is larger, so he'll be negative, and my 3 will be my positive. Okay, so if you need more help factoring this stuff, there's an earlier video that you can watch, factoring. But now that we have this factored, I have the quantity x minus 5 times the quantity x plus 3, and that equals 0. Okay, so we're going to use our 0 property of multiplication, and we're going to say, if this product is going to be 0, either the first factor is 0 or the second factor is 0. We're not sure which one it is, so we're going to try both of them. So x minus 5 could be 0, and x plus 3 could be 0. So when we solve these, we'll add 5 to both sides, and we'll get x equals 5. And for this one, we'll subtract 3 from both sides, and we'll get x equals negative 3. So what this means is that either one of these values will work for this quadratic function, that when we plug in either a negative 3 or a 5 in, this whole thing will all cancel and we'll get 0. Well, since this is the first example, let's go ahead and show that. So over here I have my x squared minus 2x minus 15 equals 0. And let's try plugging in x equals negative 3 first. Okay, so negative 3 squared minus 2 times negative 3 minus that 15. So the quantity negative 3 squared will be 9 plus 6 minus 15 equals 0. 15 minus 15 equals 0. 0 equals 0, right? So my x equals negative 3 worked. So let's go ahead and try my x equals 5 in here. So 5 squared minus 2 times 5 minus 15 equals 0 is how I'm going to set it up. 5 squared will be 25 minus 10 minus 15. So 15 minus 15 equals 0. 0 equals 0. And yes again. So I know that worked and that worked. So my answer that I got over here, this x equals negative 3 and positive 5, is going to be correct. In the second problem, I have y squared minus 9y plus 8, and that's going to equal 0. So again, it's going to be my easy method of factoring because my lead coefficient is just 1 for this quadratic equation. So I know it's going to be y here and y here. And my constant here is a positive plus 8, so I know the signs will be the same, whether they're both negative or both positive. When I look at this linear term, this is negative, so I know that both of these will be negative. So what two factors multiply to make 8, that add to make negative 9, and they're both negative, so it'll be 1 and 8. So looking at this left side, I'm multiplying these two quantities together to get 0. But the only way that will happen is either the first quantity is 0 or the second quantity is 0. So I have to take both of those into consideration. So I'm going to set both of those individually equal to 0 and then solve them each independently. So I'll add 1 to both sides. So I'll get y equals 1, and I'll add 8 to both sides. So I'll get y equals 8. So I know my final answer is y equals 1 or 8. In this third problem, I have another quadratic expression on the left, and it's set equal to 0. So I need to factor this, and then I can set each one of the factors equal to 0. But this isn't the easy method because my leading coefficient is not a 1, it's a 10. So I can use my AC method if you want to, and you can watch that video, or if you have another method that you use to factor these, that's just fine. So the AC method says that 10 times negative 3 is negative 30, and I want factors of negative 30 that will add to make 13. So 1 and 30, 2 and 15, 3 and 10, 5 and 6. It looks like 2 and 15 will work because they're 13 apart. Okay, so I'm going to rewrite this, and I'm going to split this middle term into two terms, so minus 2m plus 15m minus 3 equals 0. And then I can use factor by grouping. So I'll take a 2m out of both of those. I'm left with 5m minus 1. Take a 3 out of both of those, I'm left with 5m minus 1. So these are the same. So 5m minus 1, and the quantity 2m plus 3 equals 0. So now I have this, got a bad boy factored here. So I have the quantity 5m minus 1 and the quantity 2m plus 3. So I'm going to take each one of those independently and set it equal to 0. Because if when I multiply I get 0, one of them has to be 0. So I'll add 1 to both sides on this one, so 5m equals 1, so m equals 1/5. Subtract 3, so 2m equals negative 3, and m equals negative 3/2. So I have two choices here. I can have 1/5 or negative 3/2 for my solution for that problem. Here's one more little shortcut if you like the idea here, so you don't have to work out and solve these equations. So if you have one of the quantities 5m minus 1, you could say change the sign, numerator, denominator. So instead of negative, it's positive 1 over 5. Positive 1 over 5. Change the sign, numerator, denominator. So negative 3 over 2. Negative 3 over 2. Because really it works out that way because if you're going to use the properties of equality, you're going to end up subtracting 3 from both sides, and it'll be a negative 3 over here, like we had. And they're going to divide by the coefficient of your variable. So it'll be the negative 3 over the 2. So that's how that works. So that's a quick way if you want to look at it that way. In this next example, I have r cubed plus 3r squared, and that's going to be equal to 4r plus 12. Well, in the previous examples, we've noticed that all the terms were on the left side and it was equal to 0. So in order to use my 0 property of multiplication, this must be the case in every problem. So I'm going to take this 4r and this 12 term, each one of them, and I'm going to move them over to the left side. So it's positive on the right side, so it'll be negative over here. My 12 is positive on the right side, so it'll be negative over here. So I'm going to rewrite this as r cubed plus 3r squared minus 4r minus 12 equals, and then that can equal as 0. All my terms are on the left, and I have equals 0 on the right. Okay, so now I'm just going to worry about factoring this. I always have 4 terms, so I'm going to use factor by grouping. So an r squared will come out of the first group, and I'm left with r plus 3. Looks like a negative 4 will come out of the second group, and I'm left with r plus 3. So I know my r plus 3's are the same, so that'll be one factor. My other factor is r squared minus 4. And then I notice this r squared minus 4 is a difference of squares, so I'll have r plus 3. And my difference of squares will also yield r plus 2 and r minus 2. So when you take each one of those factors separately, r plus 3 equals 0. R plus 2 equals 0, and r minus 2 equals 0. Because again, the multiplication property of 0 there states that if all these are going to be multiplied together and you get 0, well, one of these has to be 0. We don't know which one it is, so we're going to account for all of them. So in the first one, r equals negative 3. In the second one, r equals negative 2. And in the third one, r equals positive 2. So my values for r are negative 3 and then plus or minus 2. So that's the solution for that equation.